Reviewing all the parallelogram stuff. This is all going to be matching on the test, so you would just have to know that a parallelogram is a quadrilateral with two pairs of parallel sides. And I just did some abbreviations there. So we know that that's our basic parallelogram, and we know that the properties are our first four. Opposite sides equal, opposite angles equal, angles next to each other add up to 180, and the diagonals bisect each other. We know that a rhombus is a parallelogram that has four equal sides. So it has the same parallelogram properties, plus it's got the extra properties. Actually, diagonals bisect the corner angles, and the fact that the diagonals are perpendicular. So the extra ones here are E, diagonals bisect corner angles, and G, that they're perpendicular. Rectangle is a parallelogram with four right angles, right? With four 90-degree angles. And we've known this since elementary school, that that's a rectangle. Since it's a parallelogram, it has our same four properties, plus it has the property that the diagonals are congruent. Square has everything, so this is a parallelogram with all right angles and all equal sides. Four equal sides, four right angles. And you've known this shape for all your life practically, right? A square, all right angles, all equal sides. And that's the best shape because it has all the properties, and we'll talk about that more specifically. A trapezoid has just one pair of parallel sides. So it's a quadrilateral, but it has one pair of parallel sides. So it's that lampshade kind of look. Oops, I didn't draw that very well. Lampshade kind of look. If it's an isosceles trapezoid, it has two equal sides, and then the base angles are equal, like that. And to find the length of that mid segment would be a line in the middle. You add the bases and then divide by 2. And this Venn diagram kind of shows you how those shapes are related. So when I say true or false, is every rectangle a square? That's false, and you can show that by drawing a picture of a rectangle that's not a square. But yes, every square is a rectangle, and then I like to just replace that second word with the definition. Does every square have 90-degree angles? Of course. Does every parallelogram have four equal sides? No, because you could draw a parallelogram that doesn't have four equal sides. Is every rhombus a rectangle? No, because you can draw a rhombus with all right angles. Does every square have four sides? Yes. Does every square have four equal sides? Yes. Are the diagonals of a rectangle perpendicular? No. Are the diagonals of a square perpendicular? Yes, just using the properties. The diagonals of a rectangle are congruent. That's true. The diagonals of a rhombus are not congruent. The diagonals opposite sides of a parallelogram are congruent. That's definitely true. Opposite angles supplementary, that's false. We know they're equal. The diagonals of all parallelograms bisect each other, of course, but they're not all equal. So some true and false on the properties. The bases here would be AD and BC, the top and bottom. The two legs, AB and CD. That mid segment goes in the middle, XY. And then the two pairs of base angles, angle A and angle D, and at the top, angle B and angle C. So a lot of vocab there. Now we get into the actual shapes, right? So I started with like an easy, a medium, and a difficult of each shape. For the easy with the parallelogram, you see that the opposite angles are equal. If I subtract that from 180, I get 125 for B and D. And then, of course, the opposite sides are equal, 6 and 8. So BC is 8, DC is 6. It gets harder when you draw this diagonal in. So you get triangles. The triangles add up to 180. So angle 3 here would be 60. Angle 1, of course, is 100 because it matches. And then because of Z angles, you get a 60 here and a 20 here. So angle 2 is 20, angle 4 is 60. When you just do the diagonals and the lengths of segments, it's a lot easier. XO is 4, making XZ 8. OY is 5, making WY 10. When you have a rhombus, you still are following the angles opposite or equal, angles next to each other adding up to 180, right? But remember, all the sides are equal, so in particular 6 and 6. Remember, in a rhombus, the diagonals bisect the corner angles. So angles 1, 2, and 3 are all 20. Because the triangle here adds up to 180, this is going to make angle 4 140. This is the same one again with the 20 degrees for angle 1. Remember that the diagonals of a rhombus are perpendicular, so that's 90. And remember that this was 140, so when it gets cut in half, 3 and 4 are 70 and 70. Rectangle has all 90-degree angles, so that's nice, 90 and 90, and then the sides opposite are equal, 5 and 10, or actually 10 and 5. Here, because the corner angles add up to 90, you're going to have 60 and 30, and then it's going to reverse here, 30 and 60, and of course angle 4 is 90. And again, here with the angles, 30 degrees and 30 degrees, because the diagonals are congruent, making all of these segments equal. So you're going to have 4s all around. XO is 4, making XZ 8. OY is 4, making WY 8. The square is the easiest of them all, because it's all 90s in the corners, all 5s in this case, all the way around, so 90s and 5s. When you cut a 90-degree angle in half, you get 45 and 45, so 45, 45, 90, 90. And remember that the diagonals of a square are perpendicular, so here you got 45s for 1 and 2, and 90s for 3 and 4. Trapezoids are tricky. You've got supplementary angles here, so that makes angle R 108, and if I subtract from 180, this makes angle T 48. They're not all equal unless it's isosceles. So here you've got angles, P is 113. If I subtract that from 180, I get 67 for those two, and then the isosceles is going to match. Here you've got basically checkerboards. So angle 1 here is 72. If I subtract from 180, angle 2 is going to be 108 right there. It's hard to fit in. On the other side here, angle 4 is 40. Those are corresponding. And angle 3, 140, because those make a straight line. And then to find that mid segment, 15 plus 18 is 33 divided by 2, 16 and a half. Naming all the quadrilaterals that have all angles congruent, this would just be rectangle and square. Opposite angles are congruent is all of them. I'm just going to write them like that. Parallelogram, rhombus, rectangle, square. Diagonals perpendicular only happens in rhombus and square. And the diagonals bisect each other again happens in all of them. Our algebra questions we saved for the back, so these are adding up to 180, so I'm just going to add them up. 5x plus 30 equals 180, so 5x is 150, so x is 30. If I plug that back in, 30 times 2 is 60 plus 20 is 80, making the other one 100. In a rhombus, the diagonals bisect the corner angles, so those two are going to be equal, making x 5. In a rectangle, those two add up to 90 degrees. So this is 7x plus 20 equals 90. So 7x is 70, x is 10. It's pointing in number 41 to that 90-degree angle. So this is equal to 90. 2x is 60, x is 30. In the trapezoid, these two angles are same side interior, so they're going to add up to 180. So 20x plus 20 equals 180. 20x is 160. X is 40. Or just 4. No. Hello. X is 8. X is 8. And then isosceles trapezoid, that's when those two are equal, equals 4x. So 30 equals 3x, so x is 10. Is it convex, concave, or whatever? This one's caved in, so it's concave. This one crosses over itself, so it's not even a polygon. This is kind of normal, so it's convex. And this is curved, which is not allowed, so it's not even a polygon. Not a polygon. And then here, matching them, decagon, of course, is 10 sides, quadrilateral 4, nonagon 9, heptagon 7 is E, octagon is 8, which is F, hexagon is D6, pentagon C5, and of course triangle has 3. So if we're looking by the number of sides, 1, 2, 3, 4, 5, 6, that one would be a hexagon. This one is 1, 2, 3, 4, 5 pentagon, quadrilateral there. And there again, you're just naming it by the number of sides. So you wouldn't say rectangle, right? You would say quadrilateral. 1, 2, 3, 4, 5, 6, 7, 8. So that one's an octagon. 3 sides, of course, is a triangle. And I feel like this one's 10 sides, decagon. 2 sides next to RS would be TS and RQ. 2 vertices next to T would be S and P, no symbols. Angles next to angle T would be angle S, angle P, now you have the symbols. 2 diagonals with endpoint R are T, R, P. And then the very last thing is talking about how the angles of a triangle add up to 180, angles of a quadrilateral add up to 360. So here I have 122, so if I subtract that, that's how I got 58. And a shortcut number, this one here, is to just subtract from 90 since you already have a 90, and that gives you 23. This one here, if I add them up, 65, isn't that 180 and 103? I'm adding that up, so I'm getting like 283. And if I subtract that from 360, I think I get 77. Here, if I add those up, that's what, 195, and then is that 95? 195, 95, 10, 18, 19, so I have 290. If I subtract that from 360, I get 70. So there you have it. I know that was a long review sheet, but that's all of Chapter 6.